everyone. Welcome back. This is part second of acids, bases and salts. So in this video we are going to learn the properties of bases. So before starting with the properties, let us try to understand the meaning of a base. So if I ask you what is a base, some will tell it's any metal oxide or metal hydroxide. Metal oxide or metal hydroxide. So this is correct. Examples we can take zinc oxide. Zinc is a metal, so we can say this is metal oxide. Magnesium oxide. In hydroxides we can say sodium hydroxide, potassium hydroxide. So some people or some students, they will say these are bases, so they are correct, but some they will tell like any metal oxide or metal hydroxide which gives OH negative ions in solution, that is a base. So that is also true. Both these statements are true, but the thing is, together these two is not 100% correct definition. These two statements we can say these are partially correct. But we have to understand the 100% correct meaning of a base. So let us understand that. But you have to make sure that you know these two are characteristics of a base. So let us try to understand the definition now. So base we can say, I will write it down. See, any metal hydroxide or metal oxide, hydroxide or metal oxide, which on reaction with acid, so acids we have already discussed in the previous video, acids and properties of acids. So any metal hydroxide or any metal oxide which on reaction with acid gives us only water and salt. So this is the definition of a base. So we will try to understand it with the help of few examples. See, let us take one acid HCl and let's take us one metal oxide. We will take zinc oxide. Now we have not decided whether zinc oxide is a base or not. We are just taking it as a metal oxide. So we are reacting it with acid. I see the products which I am getting are water. So this salt from here you can see this will be the salt which you will get. It is zinc chloride. So formula you have to write as per the valencies. So I will get zinc chloride. So now I can observe when HCl, which is an acid, and ZNO, which is a metal oxide, when these two are reacting, the two products are water and salt. So this was the definition of base. So when any metal oxide or metal hydroxide on reaction with acid gives us only water and salt, this metal oxide will be a base. Now let's take another example which will give us more clarity. So now we'll take HCl, which is acid, plus let's take now lead dioxide. Lead dioxide, again metal oxide. So let's see which products we will get now. First we will get water plus salt you can see from here like this. So I get lead chloride plus chlorine gas. See, when this metal oxide is reacting with an acid, it is giving us three products: water, lead chloride and chlorine. But here it's mentioned only that metal hydroxide or oxide is a base, which will give us only these two products. So now we have got chlorine gas also apart from water and salt. So which is telling me this oxide of a metal is not a base. So you always have to remember, while metal oxide or metal hydroxide is reacting with a acid, only two products if it is giving, then that metal oxide or hydroxide is a base. So let's take one more example. Now let's take one example with metal hydroxide. So I'll take now sulfuric acid H2SO4 plus metal hydroxide will take now. Now we'll see which products we will get. So on reacting sulfuric acid with magnesium hydroxide, we will get water plus this salt you can see, magnesium sulfate. Now we can see on reacting metal hydroxide with acid, I am getting only two products, water and salt. So which means this metal hydroxide is a base. So if you are getting more than these two products, metal hydroxide or oxide will not be base. If you are getting only water and salt, this metal hydroxide will be a base. So this is the correct definition of a base. Now let's try to find the presence of a base. Similarly, like in the case we have done for acids. For acids, we have checked the presence with the help of indicators. So in case of bases also, we will use same indicators, and let's see what changes will be there in case of bases. So let's try to find it out. So we'll take same indicators. I will write it down. So indicators mean which will indicate the presence. The word is itself suggesting us, it indicates the presence of a base or acid. So now we are checking for base. Indicator, litmus. Then we have phenolphthalein. Then methyl orange. pH scale and universal indicator. So these are the same indicators we have discussed while doing the properties of acids, and I have made that video also. If you want, you can go back to my playlist and find properties of acids. Now let's see. In the presence of a base, litmus will be changed to blue color. So in case of acids, it was changing to red color, but now to show the presence of a base, it will be changed to blue color. Phenolphthalein, it will be changed to pink color. Methyl orange, it will be changed to yellow color. pH scale, we have already discussed. In pH scale we have values from 1 to 14. So in case of acids, we have already discussed, in case of acids our values was from 1 to 6. 7 is for neutral solutions. Neutral means solutions which are neither acidic nor basic. So pH scale, which shows us the values from 8 to 14, will indicate the values of a basic solution. Universal indicators, on universal indicators we have 7 colors in the form of Vibgyor. Vibgyor. So we have already discussed yellow, orange and red indicates the presence of acid. Green indicates the presence of neutral solutions, and remaining these three colors, violet, indigo and blue. These three colors will indicate the presence of a base. Now it's all clear about the indicators and the changes which can be observed in the presence of a base. Now let's do the types of bases. So in types of bases, we have two types. First is water soluble. So this word itself is suggesting any base which dissolves in water. So these are water soluble, and the other one we have is water insoluble. So insoluble, this word is suggesting us those bases which don't get dissolved in water. So there are few bases which are water soluble. So we have potassium oxide, potassium hydroxide, sodium oxide, sodium oxide, sodium hydroxide, then we have ammonium hydroxide, then calcium hydroxide. So these are few water soluble bases. So this calcium hydroxide, this is partially soluble. Partially means sometimes it will dissolve or sometimes it won't dissolve. So we consider it as partially soluble, but it comes still under water soluble bases. So apart from these bases, if there is any other base, that base will be considered as water insoluble. So you just have to memorize it. Only 6 bases are there which are water soluble. So you have to remember it, like oxide and hydroxide of potassium, oxide and hydroxide of sodium, then you have ammonium hydroxide, then calcium hydroxide. So apart from these bases, all the bases will be water insoluble. So we can take any example. For example, zinc oxide, magnesium oxide, magnesium hydroxide, calcium hydroxide. So not calcium hydroxide, because calcium is soluble. So apart from these, all are water insoluble. So you can, if you see any base apart from these and a question has been asked whether this base is water soluble or water insoluble, you just have to see if this base is not from these bases, then it will be water insoluble. Now for water soluble bases, one term is used to refer these bases, that is alkali. Water soluble bases are known as alkalis. So there is one very important question which can be asked. So you have to understand, 2 questions are there and they are very much similar. So one question it can be, are all alkalis are bases? See, just read it. Are all alkalis bases? See, all alkalis are this much. Alkalis means water soluble. So these are only this much, which means yes, all alkalis are bases. Yes. Now let's see the next question. We will just change this question. Now the question are all bases alkalis? See, we just have changed the form of the question. Are all bases alkali? See, all bases include this also, means water soluble also and water insoluble also. So can you say now that all bases are alkali? No, because only water soluble bases are alkali. So answer for this question is no. See, there is a little difference between both the questions. You have to understand it before answering it. Now all water soluble bases. Now Water soluble means bases which will dissolve in water. So once they dissolve in water, they will give us OH minus ion. This ion they will give on dissolving with water. See, do you remember the first thing while discussing the meaning of base? We have discussed bases are those which gives us OH minus ion. See, it gives but not all the bases. See, water soluble bases, they give us OH minus ions in its solution form. So this was all about the types, their categories and few properties. Like water soluble, they are known as alkalis and they give us OH negative ions. So apart from these, all the bases are water insoluble. These are few things which you have to remember, and if you want you can just make a note of this. Now let's discuss the strength of a base. Strength of base. So strength, this word is suggesting me strength means strong. So how can we come to know which base is strong or which is weak? First of all, there are very few bases which are strong, or bases are so many, but in this class we are going to study only two bases which comes under strong bases, and those are alkali, which we have discussed in the previous topic, and those bases are potassium hydroxide and sodium hydroxide. So only these two bases are included in your syllabus, and these two bases comes under strong bases. So apart from this, all the bases will be weak bases. Apart from sodium hydroxide and potassium hydroxide, all bases weak. Apart from this. So if anyone asks you which are strong bases, you can tell them alkalis are strong bases, and examples you can give sodium hydroxide, potassium hydroxide. Weak bases, all bases except these two are weak bases. We can take example zinc oxide, then magnesium oxide, magnesium hydroxide. So all the bases apart from this you can give example. Now we have to understand, or we have to find out how we'll come to know the strength of the bases. In first, while discussing the indicators, in second topic, not in first, so there we discussed few indicators. One was pH scale and the other one universal indicator. So in pH scale, we found that values from 8 to 14 are from bases. So values which while going from left to right, like 8, 9, 10, 11, 12, 13, 14. So when we are going from this side to this side, the bases will become strong. For example, if you get the pH value 13 or 14, so that 13 or 14, it will indicate the presence of a strong base. So if you get value for 13 or 14, it can be KOH or NaOH, because just now we have discussed these two are strong acids, and here we have discussed if pH values are near to 14, it means they are showing us strong bases. Strong bases means this. And in universal indicators, these three colors, violet, indigo and blue, these three colors indicates the presence of a basis. So here if we go from right to left, this side, a basis will become strong. For example, if you get violet color will indicate the presence of a strong base, which means your base either will be KOH or NaOH. So you just have to remember one thing. Strong bases are potassium hydroxide and sodium hydroxide. On pH scale, values near to 13, 14 or 11, 12, 13, 14, these will indicate the presence of a strong base. In case of universal indicator, violet or indigo, sometimes also when we go from this to this side, it will indicate the presence of a strong base. So this was all about the strength of bases. Now let's do the most important reactions of bases. So in reactions, only two reactions we are going to do now. So and those reactions comes under chemical properties of bases. So let's do it now. So the first reaction is reaction of bases with metals. So let us write the general chemical equation. Base plus metal, it will give us salt plus hydrogen gas. So all the bases, they show similar chemical reaction. That's why we are writing general chemical equation. So let's take one example now. So any base you can take, because I have already told you in this chapter we are going to take only two bases. One is potassium hydroxide and the other one is sodium hydroxide, because these are strong bases and only these two bases are included in your syllabus. So let's take now sodium hydroxide plus metal. Again any metal you can take, zinc, magnesium, calcium, sodium. So I will take zinc. Salt. Their salt is like, we will get, so one hydrogen gas, one product is sure, hydrogen gas will be evolved. See, if hydrogen is utilized, now we are left with zinc and NaO, sodium, oxygen and zinc. These are the three elements with which I am left. So these all the three will be utilized to give me a salt. This I will get sodium zincate. You can see now this is some complex compound. Now this type of reactions will be there for all the bases. Hydrogen gas will be formed as one of our product, and this is the thing which you have to remember. Now I want you to try with some other bases. You can use potassium hydroxide plus any metal you can use. If you want you can use zinc or calcium, magnesium, any metal you can use with these two bases, and just try to do the chemical reaction. Salt will be something like this, and this thing is important, hydrogen gas will be evolved. Now let's do the next chemical reaction. Neutralization reaction. So this reaction is acid plus base. It gives us water and salt. Water and salt. So this is the same reaction with which we started this video also. So this is a general chemical equation for a neutralization reaction. When acid reacts with base, it gives us water and salt. So we can try to understand it with the help of more examples. So one will take HCl plus zinc oxide. See, it's confirmed or it's shown over here, products will be water and salt. So it's easy for you. Water you can write as it is. That salt you can just try to see from here which salt we will get. So it is zinc chloride. So let's try to take one more example. Sulfuric acid plus, now we will take magnesium oxide, which will give us, it's sure it will give us water and salt. Water we will write as it is plus salt. From here we can see magnesium sulfate. Now let's take one more example. See, as of now I am not balancing the equations. I am just trying to make you understand the concept. If you want, you can just try to balance the equations also. So now let's take HCl, sodium hydroxide we can use. See, if you want, you can take different acids and different bases and you can perform different chemical reactions. See, products will be same. Water plus salt, which is sodium chloride. If you want this reaction, you can try with sulfuric acid plus KOH, or if you want, you can try with nitric acid plus sodium hydroxide, or any acid, any base you can take and try to do a chemical reaction. So products will be same. So this is a neutralization reaction. So we need to understand one thing. What is the actual meaning of neutralization reaction? See, we have discussed at the starting while discussing the properties of acid. So acid is any substance which gives us H positive ion in its solution. So here we will look. So this acid will give us H positive ion in its solution. And bases we have discussed, alkali acids, they will give us OH negative ions like potassium hydroxide or sodium hydroxide. They will give us OH negative ions. So when H positive ions react with OH negative ions, they will give us water. So basically this is a neutralization reaction. But in acids and bases, a neutralization reaction is this. See, product, water they are giving plus salt. So water we are getting from here when H positive ion reacts with OH negative ions. So with this, properties of bases have been finished, and in my next video we will discuss about the salts. So till now, if you have not seen the video about properties of acids, you can go back to my channel and search properties of acids. So after that, properties of bases, and then we'll discuss about salts. Thank you so much for watching the video. If you like, do share and do subscribe.